Alright, so we are on, let's make it a little bigger, right there. Alright, so we're just basically looking at problem set 28, and I'm looking at the practice E. Right? Just so if you watch this, you know which one I'm doing. So practice E. It says, solve this equation, and it says by graphing on a calculator. But I'm going to try to show you how to do it just algebraically, right? I don't know, you may look at this and say, oh, I like the graphing way better. But I think there's quite a few steps to that. So let's do this. What we want to do is we want to solve for x, right? We want to find what x is equal to. Alright, so let's do this. First thing I'm going to do is get rid of this 3. There's a couple ways you can do this, but I'm going to do it like this. This 3 is being multiplied by all this stuff, right? So just like in a regular algebra problem, how would you get rid of something that's being multiplied? You divide it, yeah. So I divide by 3, so I get a 1/3 over here. So I'm going to get log of 7 minus x equals 1/3. Okay. Now remember, if this says log and it doesn't have a base there, what does it automatically assume to be? It's a 10, right? So what I'm going to do is I'm going to put a 10 right there. Remember last week I talked about changing it from logarithmic form to exponential form? And he hadn't actually taught that yet until these videos this week, because I remember listening to him like, oh, I already told him that. You know, I don't know if you remember that or not, but yeah. So this is really going to be helpful, and you're absolutely right. I mean, changing it from logarithmic form to exponential can really help you solve something, and the other way around. Sometimes you can't solve for it when it's in exponential form. You got to change it to logarithmic form. So this one, I'm going to change to exponential form. So I start with the base, right, 10. I take it to the power. This is the power over here. Remember, because a logarithm equals a power. It is an exponent. So that's your exponent. So it's going to be 10 to the 1/3 power equals the number. This thing right here is the number, right? 7 minus x. You with me? So that algebra was pretty easy, wasn't it? First step was super easy. This one you had to know that rule for changing from logarithmic form to exponential form, but that wasn't so bad. And now we can get x by itself. What I'm going to do is this. Watch a little sleight of hand here. I'm going to take, since this is a negative x, I'm going to add an x to both sides, put it over here. Does that make sense? And then I'm going to take this 10 to the 1/3, which is just a number we can put into a calculator, and I'm going to put it over here on this side, so I'll subtract this. So I'm going to get a 7 minus 10 to the 1/3. Now we're ready to put this in a calculator. Now you can't go 7 minus 10 is -3. Understand that, don't you? You got to figure out what that thing is first, then we'll take it away from 7. All right? And this is where we're going to use the calculator. All right? So let's just put 10 to the 1/3. So 10 to the, I'm not sure if you need parentheses, but I'm going to put it in there since it's a 1/3. So I'm going to put 1 divided by, actually, you know what? You could just use cube root. Watch, we'll get this, I'll show you both ways. That's 10 to the 1/3, right? And that's the number right here. You could do it like this. You could take the cube root, and if I remember where the cube root is, it's under math, I think. Yep, right there. See? Cube root of something. So if I hit 4, it's going to take the cube root, because taking something to the 1/3 power is the same thing as taking the cube root of it. Right? So it's the cube root of what? 10. So let's see. Hopefully you'll get the same answer. Yep, look at that. Exactly the same. Alright, so there's a couple ways you could do that, right, if you understand. But it says 10 to the 1/3. It's just as easy, don't you think? Putting 10 to the 1/3. Alright, so now that's what that is, but we're taking 7 away from that, correct? So I'm going to go 7 minus, I think I can put answer. It's this answer. This is the last answer that I got, so I'm going to go 7 minus this, and we get 4.8 whatever. And that is the answer to this. 4 point, what's it, 8.4 something? Let's see. 5, let's go 4 places. 5.6. I think it says to go, yep, it says to go 4 decimal places. So there you go. That's how you can do it. What do you think? You like that way better than doing all that graphing? Yeah, I think it's a little easier, don't you? Now, again, there may be a reason why he's showing you, you graph the two, because your graph. What does he do here? I think he graphs. Did he put the 3 over here? I can't even remember how he did that. I think he did divide by 3, and then I can't even remember. You can look at the video and look in the book too. It goes through all the steps. And that's the thing. I mean, I think it made it a lot more confusing. I think this is a little bit better, don't you? Yep. All right. All right. That's the main thing I wanted to show you. After watching these videos, I thought, I wonder, if there's a better way to do this. And I tried it a few times, and it did. It worked every single time. So that should be fine right there. All right. Questions now.
Lesson 27, number 6 I'm in trouble with, and 7, 8, and 9.
6, 7, 8, 9?
Which is again the log of both sides.
Okay. All right, so here's the question. It gives you 3 different functions, okay? X squared plus 2, 2 to the x plus 2, and 1 minus 2 to the x. And it says which one of these right here gives you a range that is, what does it say, are all positive numbers. And when you agree that any number that's greater than 0 is a positive number? Okay, so what does it mean by the range? The range is talking about like the answer, okay? You can put in an x for this, okay? Once you put in a proper x for this, what kind of answers are you going to get? So remember, the range are all the positive numbers, okay? So anything that's greater than 0. But watch this. If I stick a number in, we'll just take one at a time here. If I stick a number in for x, it doesn't matter if it's a positive number, a negative number, or anything, okay? Even if it's a negative number, this is going to come out positive. Would you agree? So no matter what you put in here, you can put a fraction, you can put a decimal, it doesn't matter. If I add a 2 to it, this answer, or this range, is always going to be, what do you think? So not just positive, but if no matter what this is going to be some positive number, even a tiny little positive number, okay? But if I add a real tiny positive number to 2, my answer is always going to be bigger than 2, isn't it? Would you agree? Okay. Well, look at this. Is the range just the numbers that are larger than 2? No. I could include decimals, right? Fractions, 1, right? I can include 1 point whatever. So is this all the positive numbers? Is the range all the positive numbers here?
Yeah.
No.
Oh, no.
No, because like 1, right, is less than 2. That wouldn't be included, would it? Because if I stuck a number in here, I would have to add a 2 to it, right? And then I'd always have a number bigger than 2. All right, so this answer, no matter what you put in for x, this answer right here will always be bigger than 2. Does that include all the positive numbers?
No.
No, because what about all the stuff that's in between 0 and 2? They're positive numbers, aren't they? All right, but those aren't included in this function, so that's not going to work. Did that make any sense at all? All right. I'll tell you what, I'm going to skip the 3 because 2 is the answer, okay? I'm going to skip the 3 and show you that. Now, let's think about this. What if I stick a number in for x, all right, like a 1, all right? Let's put a 1 in there. Okay, so 2 to the first. What's 2 to the first?
2.
It's 2. What's 1 minus 2?
1.
1 minus 2?
Oh, negative 1.
Negative 1, isn't it? Okay, is negative 1 a positive number? No, it's not. So automatically, right off the bat, I know I'm not going to get all positive numbers for this, am I? Okay, does that make sense? Right? If I put a 2 in there, it makes it even worse, doesn't it? Because 2 squared is 4, 1 minus 4 is negative 3. That's even worse. It's going in the other direction. So this is not going to give me all positive numbers. Let's see if this one does. All right? So if we stuck a number in for x right here, I'm going to get 2 to some number, okay? Let's put like a positive, let's put an easy positive number in there. Let's put a 1 in there. 1 plus 2 is 3. This would be 2 to the 8th, wouldn't it? Okay, but I can put all kinds of numbers in for this. I could put negative numbers in for this, right? I could put positive numbers. I could put a 0 in. Put a 0 in for this. 0 plus 2 is 2. This would be 2 to the 4th. So far, my answer, my f of x, if I put a 1 in there, I get an 8, don't I? If I put a 0 in there, I get a 2. Let's go smaller than that, right? And the bigger numbers I put in, the bigger my answer is going to be. Would you agree? Mm-hmm. Let's put a smaller number. Let's put a negative in there.
Negative 2.
Let's put a negative 2. Okay. Negative 2 plus 2 is what?
0.
What's 2 to the 0? What's
1.
anything to the 0? It's 1, isn't it? Okay, so I could, if I put a negative 2 in here, I could get a 1. Is there any way to get anything less than a 1
Yes,
in here?
smaller negative numbers.
Yeah, put like a negative 2. Put a negative 2 in, we already did that. Put a negative 3 in there. Negative 3 plus 2 is negative 1. What's 2 to the negative first? That's 1/2, isn't it? So look, I can, let's scooch this over a little bit. Is this making sense? I'm just trying different numbers and putting them in, and guess what I'm getting? I'm getting a half. What happens if you go smaller and smaller negative? Like if I put a negative 4 in there, negative 4 plus 2 is negative 2, so this would be negative to the, or 2 to the negative second, which would be 1/4. Do you see that? Can I put a small enough negative where this answer will come out either to 0 or to a negative number? No, I can't. So guess what my answer is? My answer basically is all the positive numbers. You follow me? Because this will get, right, the bigger, like if I put 2 to the negative 100 power, okay, well it's 1/2 to the 100th, which is a tiny, tiny, tiny number. Still not 0 though, is it? And it still won't be negative. I could put negative 1,000,000 in for this, all right? I'm still not going to get a negative answer for this. I'll get a tiny, 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 small positive number. You get that? So there you go. That's my explanation. I don't know if it's the greatest explanation in the world, but I think that works. Okay? All right, enough of that. That was 6. Let's do 7. All right, number 7. All right, and they even give you a hint on this, on how to do this. They say take the log of both sides. So here's number 7. So that was nice of them. Gave you a little hint. Now it does say find x by taking the log of both sides. You might be able to do this another way. Watch this. Here's another way. I'm kind of flying, I'm being rebellious, okay? I'm flying in the face of what they told us to do, but I just want to show you that both ways work, okay? You could change this. This is an exponential form. You could change this to logarithmic form. Do you remember how to do that? So we're going to log base what? What's our base here? 5, right. That's our base. And then the log base 5 of what? No, because remember, x is our logarithm. So our logarithm is going to equal x. So the x always goes to the outside. This is the number. So it's going to go, so to change it from exponential to logarithmic form, this is your base, right? And this is your exponent. I forget what we used for x. We used p, didn't we, for power? And this is, I think, what do we use? N for number, all right? So this is our base. This is our p, our power, right? So it's going to be log base b of the number equals the power. What's the power? It's x. Now, you can actually do this in a calculator. You can't do it directly, but you got to use that change of base theorem. Remember that? So it would be the log 9, right, over log 5. And these are common logarithms, base 10, right, which we can do in our calculator. So let's do that. So log 9, where's my log button? Right over here. Okay, so log 9 divided by log 5. And we get about 1.37, we'll say, all right? 1.37. So you could do it that way, but they didn't ask you to do it that way, did they? They asked you to do it another way. What did they ask you to do? Find it how? By taking the log of both sides. So let's try it that way, and we'll compare it and see which one we like better. Okay. Now, as far as a test or something, I'm not going to look to see if you did it the way they told you to do it. I'm just going to look to see if you got the right answer. Okay. But I guess they're trying to just warm you up, lead you up into something. Okay. So let's write it again. 5 to the x equals 9. Now it says let's solve for x by taking the log of both sides. So watch. The log of 5 to the x equals the log of 9. Okay? Now we have a rule. See this x right here? When you have a log in front of it, do you remember what we can do with that x? It's called the power rule. Yeah, put it out in front, exactly, and multiply it. Remember that? That's a really important rule to remember. So what would that look like? That would be x log 5 equals log 9. Because logarithms really aren't that hard if you just know the rules that work with these things. That's like all math, really. It's really not that hard if you know all the rules, but there's tons of rules to learn, right? That's the hardest part about it. All right, everybody good so far? All right, now we want to get x by itself, right? Now this log 5, this is just a number that I can put into a calculator. So this is just a number that's being multiplied by x. So how do I get rid of a number if it's being multiplied by x? For instance, if I had like 3x equals 12, how do I get rid of that 3? Yeah, just divide. And this log 5 is just a number. I can take my calculator and I can stick log 5 in my calculator and get some number out of it, right? It's being multiplied by x. So how do I get rid of it? I divide by log 5. Now, does it look familiar now? Look at that. That's the same exact thing as what we did up here, isn't it? Isn't that cool? So now we just punch in the numbers and it's going to be the same exact answer, isn't it? Right? Because I put the same thing in here. So what's that? 1.37? All right. Does it say how many places to round? It says 4, but okay, put 4 in there then. But that's basically all you do. Does that help a little bit? All right, good. What else? Oh, we got the rest of them to do, don't we? So we just did 7, now we're doing 8. This is 7 to the 6x plus 3 power equals 2. Now, again, we could do this by just changing it from exponential form into logarithmic form. I'm not going to do it 2 ways every single time, okay? So we'll just do it the way that they told us to do it. We'll stay with the rules here. So we're going to take the log of both sides. So we're going to take the log of 7 to the 6x plus 3 equals the log of 2. Now we're going to apply that same exact rule that we just did earlier. So what are we going to do there?
We're moving the 6x plus 3 and multiplying it times the log 7.
Exactly. That's called the power rule. Okay, we take that exponent and we can chuck it out in front of this thing right here. So I'm going to go 6x plus 3. Now watch, since it's being multiplied by the log of 7, I'm going to put it in parentheses just to be careful. All right, I think it's pretty good precaution to do that. Equals log of 2. And it's really not just a precaution, because if I didn't put the parentheses there, then it would just be the 3 that's being multiplied by the log of 7, and then plus the 6x. Does that make sense? So you're multiplying this whole thing, so I think it really is important to put the parentheses there. All right, now again, what are we trying to do? We're trying to solve for x, right? So now we work this just like it was a regular algebra problem. Now remember, this is the thing that a lot of students don't see. The log of 7 is just a number, okay? Some decimal number, right? For instance, if I just put it into a calculator, log 7, see, it's just that number right there, right? I'm not going to type that decimal and stick it here, okay? I'm going to work with it with log of 7. It's a little easier to work with that way. But just remember, log of 7 is just a number. Log of 2 is what? It's just a number, isn't it? Okay, so you could do this a couple different ways. Trying to think of the best way to do this. Some people would distribute the log of 7 through here, because it is just a number, isn't it? Mm-hmm. Some people might just divide by a log of 7. Which way do you want to go?
I divide.
You like dividing it? Okay. So we'll divide both sides by log of 7. So stretch that out there, and then log of 7. So that cancels, right? And then that's just going to be a number. I'm not going to punch a number in my calculator yet. I'm going to wait until I'm all done solving for x. Then I'm going to take it and just put it all in the calculator at once, okay? A lot of people do this. Log of 2, and they put in the calculator, they round it, right, to 4 decimals. They put log of 7, they round it. Then they divide, and they get another rounded decimal. That's too much rounding, okay? Way too much rounding. Wait until the very end. Throw everything in the calculator at the end, then round it at the end. You got it? So we've got 6x plus 3. I'll just rewrite it a little bit neater. Equals log of 2 over log of 7. Now it's just basic algebra skills right here. So if I want to get x by itself, what do we do?
Subtract 3.
Subtract a 3. Good. So that goes away. And then what do we do? Take that whole thing and divide it by 6. It's a little ugly looking like this. It might look a little prettier if we would have distributed, but you're going to get the same exact answer. So that's what x is equal to. So we're going to take all that mess, we're going to chuck that into a calculator. All right? So let's give it a shot.
He did a really large one like this, and he did double parentheses versus started with a parenthesis,
Yeah.
then he plugged log in, and then at the end to divide it all, he ended the parenthesis and then he divided
Yeah.
it.
Yeah, I kind of scanned through it a little bit because I needed to watch all 4 of them last night, and I didn't get home. I shot a field hockey game. I didn't get home till like 8:30, and I was like, oh man, I still got 4 videos I got to watch. So I was like, it still took me a good hour and a half, but I skipped through a lot, so I might have skipped that. But that's exactly right. You're gonna have to double up some parentheses and that kind of thing. Or you could do this. You could do it a couple ways. Let's do it like this. Let's just go log 2 over log 7. All right. So I'm not even going to put parentheses on this. So log 2, except for, actually, let's clear that again. Let's try it again. Log 2 parentheses. For some reason, I don't even know if you need that or not, but I think you do because, yeah, I always do that too. So log of 2 divided by log of 7. All right. And then hit enter. And then what you can do is you can hit minus. See, it already puts the answer there. And then hit 3, then hit equals or enter. That's that answer right there. Then you can take that answer and divide it by 6. So if I hit that, see what it did? It took that answer for that whole top right there. I just divided by 6, and that's my answer right there. Weird looking answer. And this is basically just a skill thing. You know, it's just so you get used to using these laws for logarithms and that kind of thing. All right, and that would be your answer. Okay, here's number 9. I mean, to your normal person, somebody would look at this and say, you know, how is this even a logarithm problem? But you would be completely stuck. If you just had to do this algebraically with no logarithms, I mean, you wouldn't even know where to start, would you? Nah, it would be almost impossible, if not impossible, to do this without logarithms. So we're going to do what they told us to do, take the log of both sides, because this just gives us some flexibility, right? It gives us some more rules that we can work with, and it gives us some options that we can do. All right, same. This is like the 3rd time now we've done this rule, isn't it? Yeah. Take this 1 minus 4x and stick it out in front. All right, and it's going to be log of 1 over 8 equals log 6. All right. So let's do what we did earlier. This is basically the same problem, isn't it? Except they just threw a fraction in here. Really, that's the only difference. So let's do it real quick. Divide both sides by log of 1/8, right? And then do what? Minus 1. And then divide that whole thing by -4. Chuck it all in your calculator and you're good to go. You can do the rest of that yourself, can't you? Yeah, that was pretty close to what number 8 looked like. All right, what else you got? Okay, so we're going to, what problem set was that again? Sorry. 29. Okay, problem set 29, number 13. All right, let's see what we got. We got log x plus log of x plus 6 in parentheses. Good, I'm glad you asked me about this one because this we applied another rule that we haven't talked about yet today. All right. Remember he did that whole thing with, like, I forget what he used exactly. He used m and n, I think, didn't he? Like the log base b plus the log base b of n equals. So watch this. If you have a log, they have to have the same base. Like that's why I put a b on both of them. They have to have the same base. But if you have the log of a number plus the same log, right, the log base b of another number, then what you can do is this. You can just write one logarithm. You don't have to write 2 separate ones, but what do you do with the m and the n? You multiply them together. And he did go through the reasons for that. I'm not going to go through that. Basically, well, I guess I will. It's like this. Like if you had x cubed times x to the 5th, what was the rule? This is a multiplication problem, isn't it? But what did you do with your exponents? You didn't multiply the exponents together. You added the exponents. That's x to the 8th, isn't it? So you actually added the exponents. It's kind of like this. Remember, a logarithm is an exponent. It's just another way to write an exponent. So it took, you could go both ways, right? You could go from this to this, right? So what happens? You multiply them together. What do you basically end up doing? You basically end up separating them and adding the exponents, right? That's kind of where that rule comes from. And he discussed that a little bit. I did see that part. So let's do this. If these things are being added together, what can we do? We can do one logarithm, and then what are we going to do with this and this? Yeah, we're going to multiply them together, aren't we? So let's do that. And let's just write it out first before we distribute, okay, just so you see what the rule is. Okay? Now, we got another rule. You could go through the whole process again, but remember he had a little chart of different rules to kind of remember. This was one of them. This is how I say it, all right? This is just, I just have a simple mind, all right? I don't think real deep like a lot of people do. So this is how I think about it. Watch this. The log of this stuff equals the log of this stuff right here, okay? Or that. I say this, the log of this equals the log of that. So this equals that. I told you that was simple. Or you're like, that confused me more than anything. But if you take the log of something and equals the log of something, guess what's going to happen to these somethings? They're going to be equal to each other. So basically, what just happened to the logs? They just cancel out. They just disappear, okay? So what I can do is I can write x times x plus 6 equals 7. You're not really dividing by a log, because a log isn't a number that you can divide by, all right? But he does go through there. I mean, there are reasons. We're not just going to sit, just showing you how to do the problem right now, okay? Now, how in the world do you work with this? Well, let's distribute, put the 7 over on the other side. It's going to be a quadratic, and then we solve the quadratic, okay? So it's going to be x squared plus 6x. Let's take the 7 and move it over to the left-hand side, set it equal to 0. Now, does this factor? Yeah, it actually does. Okay, they rigged this a little bit for us, didn't they? So it comes out pretty easy. So put an x here and an x here. Now remember, it has to be, they have to multiply to be -7 and add up to be a positive 6. So 7, positive 7 and -1. Okay, so that works. Now, what do we do when you have a product and it's equal to 0? Set them both equal to 0. And at this point, you may not even have to set these equal to 0. You might be able to just do this in your head. All right, so you could just say x is -7 and x is positive 1. But I just showed you the steps. Oh, before I circle them, you got to be careful. What did he say? Remember he talked about the argument? If you take the log of something, a number, this thing right here is called the argument. Do you remember that?
Oh, you gotta plug them back in and make sure they don't.
Yeah, and the argument always has to be positive, okay? It always has to be greater than 0, right? So this has to, and he went through an explanation. I'm not going to go through that, but just remember that. The argument has to be positive, greater than 0, okay? So let's do this. What are our arguments? Well, right here, right, that's an argument, and so is that. Whatever you're taking the log of, that's called your argument. So, can I put a -7 in for x? No, I can't, because then I would be taking the log of a negative number. I'm not allowed to take the log of a negative number, so I got to throw it out. That's right. So it's not that it has to work in both of them. It has to work in all of them, okay? Even if it doesn't work in one of them, it's not going to work, okay? For instance, if my answer was like -4, would -4 work here? Yeah, because -4 plus 6 is 2, right? So yeah, that's fine. But will a -4 work here? No, it won't, all right? So don't just automatically knock off the negative answer, because sometimes, depending on what your arguments are, sometimes you can get a negative answer for x, okay? And that's what some kids do. They'll say, oh, he said you can't have a negative answer. No, that's not necessarily true. You can't have a negative argument, right? Now, in this situation, x is your argument, so no, you couldn't have a negative answer, could you? Right? Does that make sense? Can you have a 1? Can you put a 1 in here? Sure, I can take the log of 1, right? It's a positive number, it's fine. Can I take the log of 1 plus 6, which is 7? Yeah, absolutely. I can do that, that's fine. So what's my answer? It's just x equals 1. Does that make sense? Okay. And he went through some explanation on why you can't have a negative argument, and normally I would do that if I was teaching it from scratch, but we're just going over how to do problems right now, so we don't need to go through that. All right.
And then on the same lesson, I had trouble with number 7.
7. Okie doke. It says rewrite it as a single log. All right. Let's take a look at that. What color I want we used? Anything pretty up here? Let's use blue again. I like the blue. Let's see. What is it? Log base 3 of x minus 4 plus log base 3. Basically, it's just using that rule. We call that the product rule. Remember that thing where I put the m and the n? Where did I do that? Nope. Oh, there it is. Okay. Yeah, that thing right there. It's called the product rule because these two things are being multiplied together, right? So when things are being multiplied together, you can separate and put a plus in between, right? If you already have a plus in between, you can combine it into a multiplication. So that's basically the rule that we're going to use for this, okay? Now, we do have the same bases, right? And it's important. If this was like log base 7 of x plus 4, you couldn't do anything with it, all right? You couldn't use that rule. They have to have the same bases. All right, so if I wanted to rewrite this, watch, I can just put the log base 3 of what? What am I going to do to this argument and this argument?
Divide. No, multiply.
Multiply because of that plus. Okay, that plus means you're going to multiply. If it was minus, then what would we do?
We would divide.
Divide, exactly. Okay, so I'm going to put x minus 4 and then times x plus 4. And this is multiple choice. Do they give you that? They don't give you that, but you distribute. Yeah, yeah, you can multiply it together because this is one of your choices. And that's an easy multiplication. This is a difference of 2 squares. Do you recognize that? Remember we talked about difference of 2 squares? Because they're both the same except one's plus and one's minus. So remember your outside and inside will add up to 0. So that's just x squared minus 16. That is one of your choices, isn't it? Yep, D. And so that would be how to do that. All right.
And then I had one problem with natural logs.
Okay.
In lesson 30, problem 17 and 18.
Okay, give me a page number.
291.
291. And you said what number? 17?
17 and 18.
Okay. All righty. So it's problem set 30. And we're doing 17 and 18, right? All right. So number 17. Natural log. Now remember, when you see natural log, that's the same thing as saying log base what? E, right? And E is approximately 2.718, blah, blah, blah. Yeah. And it looks like if you put E on the calculator, he didn't mention this, and I think it's kind of important to do that. And I wish I had internet connection here because I could go to a website that will take out E to like, you know, like 1 million places, or literally like 1 million places or something like that. Not that we need it, that's just ridiculous, but if you put E on the calculator, so what are we going to do? We're going to go second function, see where it's hard to see on this calculator, but it's E to the X up here, right? So I hit that, so it says E to what power? Well, E to the first, right? So remember, yeah, he showed this on his calculator. His calculator is even harder to see than mine. You know, it's really crazy looking, but that looks a little cleaner right there. So this is just E to the first, so it's going to tell me what E is, correct? And there it is, 2.718281828, and it looks like it starts repeating, doesn't it?
Yeah,
1828, 1828. You would think the next 4 digits would be 1828, but it's not. All right, and it just starts some random crazy numbers. And it's like pi. You know how pi is 3.14159, blah, blah, blah. And it just starts crazy. And it never does repeat a pattern, does it? Okay, same thing with this. Even though in this calculator it looks like it's repeating a pattern, it really doesn't. And if you want, if you really are bored someday, you know, check out the internet, just Google it. What is E? What is the value of E or something like that? And you'll see, you know, there's computer generated things and it'll take you out, you know, to 1,000 places or whatever. And you'll see right after this, it starts changing the pattern. All right. So it's called an irrational number. All right. I just thought it was good to show you that because he didn't say that.
Yeah.
And it kind of looked like it repeated the pattern. Anyway, let's do this. So what are we trying to do to this anyway? Just oh, equals 5. I was going to say, what am I going to do with that? I need something. All right, yeah, so we're going to solve for this. So you could do this a couple different ways. I'm not going to do all these problems 2 different ways, but let me just show you. ln is the same as log base e, isn't it? I just want to show you how this works. So you could change this from logarithmic form to exponential form. How would you do this? Take the base to the power, remember this is the power, right, equals x cubed. All right, and how would I solve for x cubed? Take the, not the square root, the cubed root, right, because I want to get rid of a cubed, so I would take the cube root. So you could do this, all right, and cube root e to the fifth. That's a crazy number, isn't it? Well, we know how to do e already, right? So watch, e to the fifth, okay, that's that number right there, but we want to take the cube root of it, right?
You go under math.
Yeah, I guess you do the math thing, right? And then, is it 3? It's 4. Right, so the cube root, we could just put answer in there. Do you know how to get to the answer? Hit second function. See where above this little minus, there's an a and s. And then you don't have to rewrite the whole thing again.
Yeah.
Okay, so it's the cube root of the last answer that just had up there, and that's about we'll just say 29. 5.29, approximately. Okay, these are all approximations. All right, so that's one way you could do it, but here's another way you could do it. You could, let's see if they tell you, it doesn't say, does it? They just say solve for it, okay. You could do this. I don't know if you remember this, but if you have like e to the ln of x, do you remember what happens here? The e and the ln kind of cancel out, so that's just an x, all right? So watch what happens. So what I'm going to do is I'm going to go e to the ln x cubed equals e to the fifth, okay? So basically, I just made a base of e on both of these. Does that make sense? And so it cancels out. That's why I did it, okay?
Oh, and that's just like...
So, boom, right. That goes, and then watch, x cubed is e to the fifth. Take the cube root, it's exactly this, isn't it? All right? But I don't know if one way is easier than the other, to tell you the truth. But you like the first way better? Yeah. Yeah, sometimes, because you change it from ln to a regular log base e, right? Sometimes that's helpful, you know? But knowing the rule is helpful here too, but you might forget that. But changing from logarithmic to exponential is usually something that you do so many times, it's kind of like second nature to you. Okay, we got time for maybe one more.
So it looks like the next problem.
The next one?
The LNs are going to disappear.
Yeah, exactly. Well, you got to be careful. They're not just going to completely disappear. You got to do something first because.
First you got to distribute or get add the two together.
But is it right? Exactly. It's not really. You're not really adding these together, are you? Because you got natural log. Remember, this is log base e, right? So they both have the same base. So you can just write natural log of x times x minus 1 equals the natural log of 6. Now watch what happens here. Remember, log of this equals log of that? All right, I say that all the time. I mean, I just kind of like, to me that makes sense. The log of this equals the log of that, so this equals that. Basically, the natural logs just cancel out. And now you got a quadratic again. I'll let you solve that. Yeah, move the 6 over, set it equal to 0. So it's going to be what? Negative 3 plus 2. So x is 3, x is negative 2. You can't use negative 2, so x is 3. Did you get all that?
Yeah.
All right. All right, so does that help a little bit with logarithms?
Yes.
They're not quite so bad, are they? I mean, they're a little scary. You know, the first time you ever saw logarithms, you're like, what in the world is this stuff? But after you learn the rules and you learn how to, it's basically not any much harder than just doing regular algebra stuff, to tell you the truth. After you get used to it, you know, at first I could definitely see where it gets confusing. But if you learn the rules, right? Learn this product rule, learn the power rule, learn how to change it from exponential to logarithmic form. That's the biggest thing. If you can do that, that'll really, really help you out on a lot of stuff.
Oh, did you want to check our homework?
Yes, I do. And then we can go. All right. That's it.